Hello friends, welcome back to JEE Blunders, where you learn the don'ts first. So today I'm actually making a video after a very long time, and I thought I'd start a new series on trigonometric equations because this is one area where I have made personally quite a few mistakes. So I wanted to share them so that students can benefit from them by not making the same mistakes. So let's get started with this problem that we have here. So we want to solve sin x plus cos x equals 1. So this looks quite straightforward. So let's try it. So I want to start off by squaring both sides because that will simplify this equation. So sin x plus cos x the whole squared equals 1 squared, which is 1. And now if we expand this, we get sin squared x plus cos squared x plus 2 sin x cos x equals 1. Sin squared x plus cos squared x, that equals 1 from the trigonometric identity, and 2 sin x cos x equals sin 2x from another identity. So 1 plus sin 2x equals 1. That means sin 2x must equal 0. Correct? And if the sign of something is 0, the something must be an integer multiple of pi, where n belongs to the set of all integers. So x is n pi by 2. Let's try, just as a check to make sure this is the right solution, let's try writing down different values of x for different values of n and see whether they satisfy the original equation. So let's just try just a few, starting from n equals minus 3, so that gives us minus 3 pi by 2, n equals minus 2, so that's minus pi, n equals minus 1, so minus pi by 2, n equals 0, n equals 1, n equals 2, n equals 2, and n equals 3. Right? So, and this keeps going on. We have infinitely many solutions as there are infinitely many integers. Let's just see whether these satisfy the original equation. So x equals 0. Sin 0 plus cos 0. Sin 0 is 0, cos 0 is 1. So 0 plus 1 is 1. Yes. Sin pi by 2 plus cos pi by 2. Sin pi by 2 is 1, cos pi by 2 is 0. So 1 plus 0 equals 1. So these are correct. Sin pi plus cos pi. Sin pi is 0, cos pi is minus 1. Interesting. This is actually not a solution. And let's try some of the other values as well before we think about why we got this. Sin 3 pi by 2 plus cos 3 pi by 2. Right? Cos 3 pi by 2 is 0. Sin 3 pi by 2 is okay. Just to make sure I don't make any silly mistakes, I'm just going to label, make sure get this correct. So 0, we have pi by 2 radians, pi, and 3 pi by 2. So sin 3 pi by 2 is right here. So that should be minus 1, right? So sin 3 pi by 2 plus cos 3 pi by 2 is minus 1 plus 0. So that is minus 1. So that is also wrong. Sin of minus pi by 2 plus cos minus pi by 2 is also minus 1. So that's not correct. Sin of minus pi plus cos of minus pi is what? Sin minus pi is 0. Cos of minus pi is cos pi, which is minus 1. So this is wrong. And it looks like we are seeing a pattern here, right? We're seeing 2 correct solutions and then 2 wrong solutions. So I'm expecting this one to be correct, but let's just check. So sine of minus 3 pi by 2 plus cos of minus 3 pi by 2. Cos of minus 3 pi by 2 is 0. Sine of minus 3 pi by 2 is 1. So this is correct. So this is a really interesting thing that we found here. We definitely did solve the problem, but we ended up with additional solutions that are not solutions to the problem, right? So these values that we got here are definitely part of the solutions, whereas some of the other values we got are not part of the solutions. So why is this happening? So I encourage you to pause the video here and try to understand why this is happening. So assuming you have paused the video and are back now after thinking about it, the key issue with what we did here is that we squared both sides, right? Now, what is wrong with squaring both sides? It's definitely not wrong. If, just as a very simple example, if x, or let me use a different variable, if m equals 1, then we can for sure say that m squared is also equal to 1, right? But once we square it and we try to get back m, what do we do? What do we get? Once we square it, so we started off with m equals 1, we squared both sides. Now let's just say we want to get back the original value of m. Now we cannot come up with a unique solution of m that equals 1, because we also get the solution that m is minus 1. So this is really what happened here. Squaring an equation produces additional solutions, or what are known as extraneous solutions. And so while squaring in some situations can really simplify the equation and help us solve the equation, we almost always need to check the solutions and remove what we don't want, right? So that is the lesson learned. So just to reiterate, the important lesson to be learned is that squaring produces I think this is the technical word for it. It just means you get solutions, extra solutions, extraneous solutions. And so especially in trigonometric equations where you generally have infinitely many solutions, it's important to check them, identify the pattern, and rewrite the original solution. Alright, so that is the lesson learned. And before we finish, I just want to give you guys one more tiny question, or question that hopefully gives you some food for thought. Now we talked about squaring, right? Why just squaring? Let's say we have this is just an example. I don't know if this is actually problem, but let's say we have a problem that's like sin x to the power of 2 by 3 plus cos x to the power of 2 by 3 equals some constant, and we want to solve this. So the first thing that I am tempted to do is to cube both sides, because when I cube these two terms and add them, I'm going to get sin squared x plus cos squared x, and that is going to simplify the math for me. But do I have to k cube. Now do I have to do the same exercise that we did? Do I have to really be very careful and say, okay, let me check the solutions one by one? and then remove the unnecessary solutions, or can I be a little more relaxed when I cube something? And hopefully that gives you some interesting insights into the difference between squaring and cubing. And with that, I will see you all in the next video. Thank you.